I watched the meters climb while my report sat unread on a metal desk. I fixed the radios they ordered back into service, knowing they would speak where they should not. My superiors wanted transmission, not containment. I kept writing the failures in a ledger no one asked to see. In the first week of May in 43, Allied forces were consolidating their positions across northern Tunisia after the final collapse of Axis resistance in North Africa. The campaign had ended only days earlier. Ports at Bizerte and Tunis were still congested with damaged ships, fuel barges, and improvised repair crews. Airfields inland were crowded with transport aircraft and temporary radar installations. Along the coast, signals units began the slow work of rebuilding long-range communications networks that had been damaged by months of bombing and retreat. The broader operational situation was defined by preparation rather than combat. British and American commands were planning the next phase of the Mediterranean War, an amphibious landing on the southern coast of Europe. Although the name Operation Husky was already circulating in high-level correspondence, most personnel knew only that a major seaborne operation was being assembled somewhere beyond the horizon. Orders emphasized secrecy, radio discipline, and compartmentalization. Few outside planning staffs were told more than was necessary to perform their assigned technical duties. One of the many units reassigned to this transitional period was the 36th Signal Repair Section, attached to the US Army Signal Corps and operating under the Northwest African Tactical Air Force. Its workshop occupied a former French customs warehouse on the eastern edge of Bizerte harbour. The building had a leaking roof, salt-stained walls, and doors that did not close properly in the wind, but it offered space for benches, storage racks, and a small generator shed. Crates of spare vacuum tubes, copper wiring, and field radio sets were stacked between sandbags and empty fuel drums. Among the technicians assigned to the section was Corporal Daniel Mercer, aged 27, originally from rural Ohio. He had been trained at Fort Monmouth as a radio maintenance specialist in 41, shipped to England in early 1942, and then reassigned to North Africa following the landings in November of that year. His service record listed him as competent, quiet, and reliable. He had no disciplinary actions and no commendations. Mercer's work was routine and rarely visible outside the workshop. He inspected damaged SCR-284 transmitter units, cleaned corrosion from frequency dials, replaced cracked insulation, and logged each repair in a narrow ledger kept in the section office. The pace of work was steady. Air units rotated equipment constantly, and naval liaison teams brought in shipboard radio components affected by the saltwater exposure or vibration damage. Most of the repairs were simple, but supply shortages made improvisation necessary. Mercury switches were salvaged from wrecked bombers. Copper wire was stripped from obsolete telephone lines. When replacement parts could not be sourced, Mercer and the other technicians rewound coils by hand. In the weeks following the end of the Tunisian campaign, the workshop was busier than it had been during active fighting. Aircraft were flying longer patrols, new convoy routes required additional relay stations. Temporary listening posts were established along the coast, some of them only tents with wire masts anchored by sandbags. Each installation depended on functioning radios. Mercer worked 12-hour shifts, sometimes longer when priority equipment arrived. He slept in a shared tent behind the warehouse and ate in a nearby field kitchen. Letters from home were irregular. He did not complain, and he did not volunteer for additional duties. When not repairing equipment, he assisted in calibrating transmitters for field deployment or testing receivers against known broadcast frequencies. By mid-May, his ledger entries showed that he had personally repaired or inspected over 100 individual units in 3 weeks. The operational environment emphasized speed and secrecy. Orders were transmitted verbally when possible. Written instructions were limited and coded. Signal officers warned technicians not to discuss destinations or unit movements, even casually. Mercer followed these rules carefully. His interactions were limited to technical exchanges, serial numbers, voltage levels, signal clarity. Several days into the month, the section began receiving a different category of equipment: long-range naval transmitters intended for ship-to-shore coordination. These sets were larger than the aircraft radios and more sensitive to frequency drift. They were scheduled to be installed on transport vessels assembling in Algerian ports. Mercer noticed that many of the sets arrived with inconsistent tuning. Some had been damaged in transit, others appeared to have been adjusted multiple times by previous crews. He began recording irregularities in the margins of his ledger. unstable oscillation at higher power settings, faint distortion when switching between preset channels, intermittent signal loss during sustained transmission. He brought these observations to Sergeant Harold Beckett, the section's senior non-commissioned officer. Beckett acknowledged the notes but had limited authority to delay deployment. The equipment was needed quickly, and replacement units were scarce. "Make them serviceable," Beckett said, according to later recollections from personnel. "That's the order." Mercer did what he could. He replaced worn capacitors, reinforced loose solder joints, and rebalanced tuning circuits. In some cases, he had to return units to service despite lingering instability, noting the limitations on their inspection tags. During this period, Allied Command was intensifying radio silence measures for operational units involved in amphibious training. New protocols restricted transmission windows. Dummy traffic was introduced to confuse enemy monitoring stations. Technical personnel were instructed to maintain strict discipline regarding frequencies and call signs. The increased complexity of radio traffic placed additional strain on equipment already operating near its design limits. The Mediterranean climate accelerated corrosion. Dust from inland winds infiltrated enclosures. Power supplies fluctuated with the unreliable local generators. By late May, Mercer began noticing patterns in the repair requests. Certain transmitters were returning repeatedly for adjustment. Others exhibited identical forms of distortion after only short periods in use. He suspected a systemic issue, either with a batch of components or with the calibration procedures being used at installation points. He compiled a short memorandum listing the serial numbers affected and the symptoms observed. The document was submitted through his chain of command but received no immediate response. There was no indication that higher headquarters reviewed it. The workshop continued operating at maximum capacity. Outside the building, the harbour changed daily. New ships arrived, others departed at night without markings. Troop movements increased along the coastal road. Military police enforced new access restrictions around certain piers. The details were not shared with technical personnel, but the scale of preparation was visible. Mercer observed these changes without comment. His role remained confined to the interior of the warehouse, where the air smelled of solder smoke and damp wood. He kept his tools clean, his records precise, and his opinions limited to equipment performance. On the 28th of May 1943, a consignment of naval transmitters arrived from Oran with orders for immediate servicing and return. The accompanying paperwork was stamped Priority Movement. Mercer worked through the night inspecting 3 of the sets. 2 displayed familiar instability at high output levels. The third, an SCR-299 variant adapted for shipboard use, showed an unusual anomaly. Faint carrier bleed into adjacent frequencies when tested under sustained load. The signal was weak, almost indistinguishable from background noise, but measurable. Mercer repeated the test several times. The anomaly persisted. He noted the behaviour in his ledger and marked the unit for extended calibration. Before he could begin disassembly, an officer from the Naval Liaison Detachment arrived to collect the equipment. The officer accepted the documentation but declined to delay shipment. The transmitter left the warehouse before dawn. No formal report followed. By early June, similar anomalies were appearing more frequently. Some receivers were picking up unintended fragments of coded transmissions during routine testing. The fragments were incomplete and meaningless in isolation, but their recurrence suggested that certain frequencies were bleeding beyond their intended channels. Mercer recorded the incidents but did not attempt to interpret them. He had no access to codebooks and no knowledge of operational content. His responsibility ended with mechanical function. The section's workload increased further as new relay stations were prepared along the coast. Signal officers emphasized speed over precision. Minor distortions were tolerated if transmission could be maintained. Mercer continued repairing equipment, often reworking the same units multiple times. The effort went unacknowledged beyond brief nods from supervisors. His name did not appear in operational reports. His work was listed under equipment readiness statistics, aggregated with dozens of others. By the second week of June, the workshop generator began failing intermittently, forcing technicians to test equipment using unstable external power sources. Voltage fluctuations worsened existing calibration problems. Mercer noted that the interference artifacts were becoming more pronounced under these conditions. On the 12th of June, he prepared another memorandum detailing the increasing frequency bleed and the potential risk of unintended signal propagation. The document was forwarded to the section office. It received no reply. That evening, as the sun set over the harbour and the movement of ships slowed, Mercer remained at his bench adjusting a receiver dial to eliminate a faint oscillation that would not fully disappear. Outside, preparations for the coming operation continued, guided by plans known only to a narrow circle of officers. Inside the warehouse, the work remained mechanical, repetitive, and largely unseen. By mid-June 1943, Allied preparations along the North African coast had entered a new phase. Convoys assembled at staggered intervals in ports from Algiers to Sfax. Amphibious training intensified offshore. Airfields expanded their perimeter fencing and imposed stricter blackout regulations at night. The accumulation of personnel and material was no longer subtle, even to those excluded from operational briefings. Within the signal repair warehouse at Bizerte, the tempo of work increased accordingly. The 36th Signal Repair Section received equipment in near-continuous rotation. Shipboard transmitters arrived coated in salt residue. Portable relay sets returned with cracked casings from rough handling. Aircraft radios showed signs of vibration damage from extended patrol flights over the central Mediterranean. Corporal Daniel Mercer remained at his assigned bench, logging serial numbers and replacing components with practiced efficiency. He rarely left the building except to eat or sleep. His uniform bore no distinction beyond the insignia of his rank and branch. He spoke little, and when he did, it was usually to confirm voltage tolerances or parts availability. The technical irregularities he had observed in May were no longer isolated. By 15th of June, nearly one-third of the long-range transmitters routed through the section exhibited measurable frequency instability. In some units, the drift was minor, detectable only on sustained transmission tests. In others, the distortion was strong enough to produce faint secondary carriers several kilohertz outside assigned channels. The symptoms varied, but the pattern was consistent. Equipment tested clean at low output levels and degraded when pushed to operational power. Mercer suspected that a combination of factors was responsible. Many of the transmitters were drawn from pre-war stocks, refurbished repeatedly and never designed for prolonged high-duty cycles. Replacement components were often mismatched, substituted from different manufacturing batches. Field calibration teams worked under pressure and without standardized instruments. He documented each case carefully. The ledger at his bench grew thick with annotations. Alongside repair notes, he recorded environmental conditions during testing, temperature, generator output fluctuations, background interference levels from nearby stations. The entries were precise, unemotional, and technical. Sergeant Beckett acknowledged the growing number of irregular reports, but continued to forward the equipment. "Command wants everything that can transmit," he told Mercer during a brief inspection. "They'll accept some distortion if it keeps schedules moving." The phrase "keeps schedules moving" was not explained further. In late June, the workshop received its first sets marked for use aboard headquarters vessels rather than transports. These radios were intended for coordination between fleet command elements and shore-based air controllers once landings began. They were higher-grade units, newer than most, but still subject to the same environmental stresses. Two of them displayed the same frequency bleed Mercer had already noted in earlier equipment. He requested permission to hold the units for extended recalibration. The request was denied. At higher levels, the operational doctrine emphasized redundancy and speed over technical perfection. Communications planners assumed that multiple overlapping channels and prearranged transmission windows would compensate for equipment faults. Radio silence protocols were strict but not absolute. Brief bursts of coded traffic were considered acceptable risks. Mercer was not part of these discussions. He saw only the equipment. The limitations became more evident as the scale of radioactivity expanded. Training exercises generated large volumes of short transmissions between ships and aircraft. Relay stations operated continuously. Monitoring units scanned for axis signals along the Sicilian coast. In the process, unintended artifacts appeared more frequently during workshop testing. Several receivers captured fragments of transmissions that should have been confined to higher frequency naval circuits. The fragments were incomplete and distorted but consistent in structure, short bursts of encoded tone patterns repeated at fixed intervals. Mercer did not attempt to analyze them. He lacked the training for cryptographic interpretation and did not consider it his role. However, he recognized that the signals originated from operational networks, not commercial broadcasts or atmospheric interference. On the 27th of June, he submitted a third memorandum, this one longer and more detailed than the previous two. It listed 12 specific transmitters by serial number, the conditions under which frequency bleed occurred, and the potential risk of signal interception by hostile monitoring stations operating near Sicily or mainland Italy. The memorandum was routed to the section office and stamped as received. No response followed. The workshop continued operating. By the end of the month, sleep became irregular for many of the technicians. Equipment deliveries arrived at all hours. Mercer worked through 2 consecutive nights during a surge of repairs following a training convoy's return to port. Several transmitters from the same ship showed identical degradation patterns, suggesting onboard power fluctuations had damaged internal components. Mercer replaced capacitors, reinforced shielding, and rebalanced tuning circuits where possible. The interference remained. During the first days of July, rumours circulated among the support units that the invasion date was approaching. No official confirmation was provided. Mail was suspended. Movement between camps required written authorization. Military police patrols increased along the harbour perimeter. The signal repair section was instructed to operate under blackout conditions after dusk. Windows were covered. Work was conducted under hooded lamps. The technical problems persisted into this new phase of heightened security. On the 3rd of July, a naval transmitter returned to the workshop after failing a communication check aboard its assigned vessel. The failure report cited unidentified channel noise during scheduled transmission window. Mercer tested the unit under controlled conditions. At operational power, it produced the same faint secondary carrier he had been documenting for weeks. He marked the fault clearly on the inspection tag and recommended withdrawal from service. The recommendation was overridden by a junior naval officer responsible for equipment allocation. "We don't have replacements," the officer said. "Send it back." Mercer complied. By now, the ledger entries describing frequency bleed numbered in the dozens. The pattern was unmistakable to anyone reviewing the records, yet the documents remained within the section's files, unseen by planners. On the 7th of July, weather reports indicated deteriorating conditions over the central Mediterranean. High winds and low cloud cover complicated flight schedules. Some exercises were postponed. Others proceeded under modified protocols. Radio traffic increased accordingly. That same day, Mercer observed an anomaly unlike the previous ones. While testing a receiver connected to a shipboard transmitter undergoing final calibration, he detected a brief but distinct burst of encoded signal outside the assigned frequency band. The signal was stronger than earlier instances, lasting nearly 2 seconds before fading. He repeated the test source. The signal appeared again, identical in structure. He recorded the frequency, time, and equipment identifiers. The pattern suggested that a nearby transmitter was bleeding operational traffic into adjacent channels at full strength. Mercer removed the receiver from the test circuit and connected a second unit. The signal persisted. He could not determine the content, but he could confirm the source: Allied naval traffic, transmitted from a vessel somewhere in the harbour. The implications were technical, not strategic in his mind. It meant that secure channels were not fully contained. It meant that signals intended for short-range coordination might propagate farther than planners expected. He prepared another memorandum, his fourth. This one included measured signal strength data, frequency charts, and a recommendation that affected transmitters be isolated until shielding or component replacement could be completed. He submitted it to Sergeant Beckett, who forwarded it to the section office. Again, no reply. The following days were dominated by preparations unrelated to the workshop. Troop convoys moved at night. Harbour traffic became continuous. Landing craft were loaded and sealed. Within the warehouse, the equipment turnover reached its peak. Mercer worked beside other technicians in silence, interrupted only by the hum of generators and the click of test instruments. On 9th of July, 2 days before the planned landings in Sicily, the section received an urgent order to clear all pending repairs and return every serviceable transmitter to deployment. "Everything that can talk goes out, yes," Beckett said. Mercer finished calibrating 3 units before midnight. All 3 displayed minor frequency instability. He documented the faults. The units were shipped regardless. At dawn on the 10th of July, as the first assault convoys began moving northward under cover of heavy cloud, the signal repair warehouse fell briefly quiet. No new equipment arrived. The technicians waited. Mercer remained at his bench, reviewing his ledger entries from the past 6 weeks. The records showed a gradual increase in interference cases clustered around specific equipment batches and power configurations. He had no authority to act on the information. He had no knowledge of the landing zones, the timing schedules, or the command frequencies assigned to the invasion fleet. His role had been limited to repair and documentation. By midday, radio traffic across the harbour intensified. Monitoring stations reported heavy activity. The technicians were instructed to stand by for emergency repairs. Mercer listened to the background noise on his test receiver. Overlapping carriers, faint bursts of coded tone, distortion layered upon distortion. The patterns he had been recording were now present across multiple bands. He wrote one final note in the margin of his ledger. Frequency containment unreliable under sustained load. Risk increasing. The entry was dated and signed with his initials. There was no indication that anyone beyond the workshop would read it. Outside, the invasion fleet was already crossing the Mediterranean. On the 11th of July in 43, the second day of the Allied landings in Sicily, the harbour at Bizerte resumed partial activity. Repair barges returned from escort duties. Aircraft rotated through refuelling points. Signal units along the coast reported equipment failures at a higher rate than anticipated. The 36th Signal Repair Section was ordered to full readiness before dawn. By the time Corporal Daniel Mercer arrived at the warehouse, a queue of vehicles was already forming outside the loading doors. Several carried shipboard transmitters removed during the night from vessels that had encountered communication difficulties after crossing the Sicilian Channel. The failures were not uniform. Some units had lost transmission strength, others produced erratic tuning behaviour. A few could not maintain a carrier signal for more than several seconds. Mercer began testing the first set at 0630 hours. Within minutes, the familiar pattern appeared. Secondary frequency bleed during high-output transmission. This time the bleed was strong enough to register clearly on the section's monitoring receiver without amplification. Mercer isolated the affected circuit and traced the interference to a degraded coupling capacitor combined with insufficient internal shielding. The configuration was nearly identical to several other transmitters he had repaired in June. He logged the findings and moved to the next unit. By mid-morning, 6 of the first 8 transmitters showed the same defect. One of them, according to the accompanying paperwork, had been assigned to a headquarters vessel coordinating air cover for the eastern landing beaches. Mercer marked the inspection tag in red pencil, unsuitable for operational use, containment failure. The notation was clear, but its authority was limited. Sergeant Beckett reviewed the tag and hesitated. "They're asking for everything," he said. "Fleet Command wants radios back in the water." "This one shouldn't go," Mercer replied, quietly. It was the first time he had argued a deployment decision. Beckett looked at the transmitter, then at the growing line of vehicles outside. "I'll flag it," he said, "but I can't promise anything." The unit was set aside temporarily. As the morning progressed, reports arrived from monitoring stations along the Tunisian coast. Allied signals intelligence teams detected increased enemy listening activity from Sicily and southern Italy. German and Italian intercept stations were known to be operating near Messina, Catania, and Reggio Calabria. Mercer was not informed of these reports directly, but the urgency was visible in the movement of officers through the warehouse and the tone of their conversations. Shortly after noon, a naval communications lieutenant entered the workshop with 2 assistants. He carried a list of serial numbers and requested immediate return of specific transmitters. The red-tagged unit was among them. Beckett attempted to explain the defect. The lieutenant listened briefly. "Does it transmit?" he asked. "Yes," Beckett said. "Then we need it." Mercer stood nearby holding a frequency chart he had prepared that morning. He did not speak. The transmitter was taken. By early afternoon, a second wave of damaged equipment arrived, this time from vessels that had participated in the initial landings. Some units bore signs of water exposure from rough seas. Others had overheated under sustained transmission loads. Mercer worked continuously, replacing components and recalibrating circuits as quickly as possible. The interference problem persisted. At 1500 hours, while testing a receiver connected to one of the returned headquarters transmitters, Mercer detected something new. A clear, structured transmission appeared briefly on a frequency band normally reserved for low-power harbour coordination. The signal was encoded, strong, and repeated twice within 30 seconds. Mercer froze the receiver dial and confirmed the frequency. It was outside the normal operational band of the transmitter under test. He switched to a second receiver. The signal appeared again, He switched to a third, the same result. This was no longer faint bleed-through. It was full-strength operational traffic propagating across unintended channels. Mercer recorded the frequency, signal strength, and duration. The measurements indicated that the source transmitter was operating at high power, likely aboard a vessel still offshore. The content was unintelligible to him, but its structure matched known Allied naval coordination patterns. Short burst, pause, repeat. Mercer reviewed his earlier notes. The serial number of the red tag transmitter appeared again. He located its ledger entry from June 28th, when he had first recorded its instability. The unit was now active in the invasion zone. The realization was technical, not dramatic, but it carried weight. A transmitter with containment failure was broadcasting operational traffic beyond its assigned channel. If Allied receivers could detect it in Bizerti, then enemy intercept stations across the water could do the same. Mercer brought the ledger to Beckett. "This one," he said, pointing to the entry. "It's active. It's bleeding into harbour frequencies at full strength." Beckett frowned. "You're sure?" "Yes." Beckett glanced toward the office where the section commander, a captain, was conferring with naval personnel. "Write it up," he said. Mercer had already written 3 memoranda that had gone unanswered. This time he did something different. He prepared a technical report as usual, but he also attached frequency charts, signal strength tables, and a list of specific operational channels affected. He included the serial numbers of 7 transmitters known to exhibit identical defects. Then, instead of routing the report through the normal administrative process, he asked Beckett for permission to deliver it directly to the Naval Communications Detachment Office adjacent to the harbour command post. Beckett hesitated. "That's not procedure." Mercer waited. "I think they need to see this now," he said. Beckett studied the charts. He recognized the handwriting, the consistency, the weeks of accumulated notes. "Go," he said finally, "but make it technical. No speculation." Mercer left the warehouse carrying the report folder under his arm. It was the first time he had crossed the harbour perimeter for reasons other than supply collection. The Naval Communications Office occupied a reinforced concrete building near Pier 4. Armed guards checked his identification and searched his bag before allowing him inside. He was directed to a small waiting room. After 20 minutes, a lieutenant commander named Arthur Collins agreed to see him. Mercer explained the defect in precise terms: component degradation, shielding failure, propagation beyond assigned frequency bands under sustained load. He did not mention landing plans, enemy action, or strategy. He showed the charts. Collins examined them in silence. "Which units?" Collins asked. Mercer provided the serial numbers. Collins compared them to his own list. 3 matched transmitters currently assigned to fleet coordination roles. "When did you observe this?" Collins asked. "Repeatedly since late May," Mercer said. "And now?" "Now the signal strength is higher. It's detectable at long range." Collins closed the folder. "This should have come through channels," he said. "I submitted reports," Mercer replied. "How many?" 4. Collins nodded slowly. He did not promise action. He dismissed Mercer after 10 minutes. Mercer returned to the warehouse before dusk. The equipment flow continued without interruption. No orders arrived to withdraw the affected transmitters. That night, as he worked under hooded lamps, Mercer listened to the receiver again. The same structured bursts appeared intermittently, sometimes stronger, sometimes weaker. Always outside the assigned band, he logged each instance. At 2300 hours, Beckett approached him. "They acknowledged the report," Beckett said. "Naval Command." "Are they pulling the units?" "No word." Mercer nodded. By now, the risk had shifted from abstract technical concern to something closer to personal responsibility. He had identified the defect, documented it, and delivered the evidence. Whether action followed was beyond his control. He remained at his bench, adjusting circuits and writing entries. Shortly after midnight, the monitoring receiver registered another burst of operational traffic. Mercer noted the frequency. It was unchanged. He wrote 1 line beneath the entry, "Source persistent." He signed his initials. Outside, aircraft engines droned overhead, moving north towards Sicily. Inside the warehouse, the hum of generators blended with the steady hiss of radio static. On the 12th of July 1943, 3 days into the Sicilian landings, Allied Naval Command issued a classified technical bulletin to communications units operating in the central Mediterranean. The document circulated through restricted channels. warned of irregular signal propagation observed on selected naval transmitters during sustained output. The bulletin did not specify causes. It did not list serial numbers. At the signal repair warehouse in Bizerte, the notice arrived late in the afternoon, folded inside a packet of routine maintenance directives. Sergeant Beckett read it twice before bringing it to Mercer's bench. "They're finally seeing it," he said. Mercer read the bulletin in silence. The wording was careful, non-committal. It framed the problem as an environmental phenomenon, possibly caused by atmospheric conditions or power fluctuations aboard vessels. It made no mention of defective components or shielding failures. The practical instruction was brief. Monitor equipment performance, report irregularities, and continue operations. No units were withdrawn from service. No transmitters were grounded. The equipment turnover accelerated rather than slowed. Throughout 12 and 13th of July, transmitters returned from the invasion fleet in steady intervals. Some arrived marked intermittent contact loss. Others were labelled signal distortion reported by receiving station. Several bore no written explanation at all. Mercer tested each one. The same pattern emerged repeatedly. Secondary carriers, frequency drift, bleed into adjacent channels. In some cases, the interference was severe enough to overwhelm the test receiver's filtering circuits. He recorded everything. By now, his ledger contained over 70 entries referencing containment failures across multiple equipment batches. The serial numbers formed clusters, many originating from the same pre-war production series. Mercer prepared an updated technical summary and delivered it to Beckett, who forwarded it to the section office. Beckett also added a brief cover note emphasizing that the same defects had been documented since May. There was no reply. On the evening of 13th of July, a naval courier arrived with a sealed envelope for the section commander. The contents were not shared with the technicians, but the effect was visible. The commander conferred with Beckett for nearly half an hour behind closed doors. Afterward, Beckett informed the section that repair priorities would change. "Focus on restoring basic transmission capability," he said. "Containment issues are secondary." Mercer understood what that meant. Transmitters would be returned to service as long as they could transmit, regardless of whether their signals remained confined to assigned frequencies. The decision was administrative, not technical. It reflected the immediate operational need for coordination during a complex, amphibious campaign. That night, Mercer replaced a burned resistor in a headquarters transmitter that still exhibited strong frequency bleed. He noted the defect on the inspection tag. The tag was removed before shipment. On the 14th of July, intelligence officers at Allied Naval Headquarters confirmed that Axis monitoring stations in southern Italy had intercepted fragments of Allied naval traffic. The content was incomplete and heavily distorted, but analysts concluded that it likely originated from command and control transmissions associated with the invasion fleet. The information was classified at the highest operational level. It did not reach the signal repair section. Mercer learned of the intercepts only indirectly weeks later through an after-action technical briefing document. At the time, he continued working without knowledge of the broader consequences. The pressure inside the warehouse intensified. Equipment arrived damaged by salt water, vibration, and overuse. Power supplies failed more frequently. Spare parts grew scarce. Technicians improvised repairs using salvaged components, sometimes mismatched in specification, but close enough to function. These substitutions often worsened containment problems. Mercer attempted to standardize replacements where possible, sorting parts by manufacturer and tolerance range, but the volume of work made precision difficult. During the afternoon of 15th of July, a naval communications officer returned to the warehouse to inspect repair operations. He questioned Beckett about turnaround times and equipment availability. Mercer overheard part of the exchange. "Fleet's complaining about unreliable channels," the officer said, "but they still need the sets." "Containment's still off on a lot of them," Beckett replied. The officer shrugged. "Doctrine assumes interception anyway. We're relying on encryption." Mercer said nothing. Encryption was irrelevant to the technical problem he had identified. Containment failure meant that traffic intended for tightly controlled channels was propagating beyond planned coverage areas. It increased the volume and predictability of signals available to enemy listeners. Encryption protected content, not operational patterns. But that distinction did not enter official discussions. Later that day, Mercer tested a transmitter recently returned from a headquarters vessel operating near Syracuse. The interference was extreme. The unit produced 3 distinct secondary carriers, all outside assigned bands during sustained transmission. Mercer disassembled the casing. Inside, the shielding plates were warped from heat exposure. Several insulating mounts had degraded, allowing internal components to vibrate under power load. It was a design vulnerability exacerbated by prolonged use. He could correct it temporarily by reinforcing the mounts and adding additional grounding straps. It would take several hours. He requested permission to hold the unit overnight. The request was denied. The transmitter was shipped back within 40 minutes. Mercer watched it leave the warehouse. That evening, he added a separate page to his ledger. He titled it simply, Containment Failures, Persistent Cases. He listed serial numbers, dates, and symptoms. The page was meticulous. It would never be included in any official report. By 16th of July, the scale of Allied operations in Sicily had expanded. Beachheads were secured, airfields were captured, naval coordination shifted inland. The signal repair section remained active around the clock. Mercer's involvement deepened not in authority but in exposure. He now recognized specific transmitters by memory. He could identify problem units before testing based on serial ranges alone. Each time one returned to service, he knew that its signals would travel farther than intended. He knew that enemy monitoring stations would hear them. He also knew that no order would arrive to remove them from use. The decision had been made elsewhere. On the night of the 17th of July, Mercer sat alone at his bench during a brief lull in deliveries. The generator outside sputtered and stabilized. The harbour was dark save for shielded lights on distant ships. He opened his ledger and reviewed the entries from May onward. The progression was clear. Early minor drift, gradual containment failure, full secondary propagation under operational load, weeks of documentation, multiple ignored reports. He closed the book. There was nothing more he could add that would change the outcome. Shortly before midnight, a new transmitter arrived from a fleet command vessel. The accompanying note read, "Signal quality compromised during coordination with air units." Mercer unpacked the unit. It was another from the same defective batch. He began the familiar procedure, testing, measuring, documenting. Outside, the war continued moving northward. Inside the warehouse, the equipment continued to speak beyond its assigned channels. In early August 1943, as Allied forces completed their consolidation of Sicily and began preparing for operations on the Italian mainland, the pace of emergency equipment repair along the Tunisian coast finally slowed. Convoys shifted northward. Headquarters vessels relocated to newly secured ports. The flow of damaged transmitters into the warehouse at Bizerti decreased from dozens per day to a few per week. For Corporal Daniel Mercer, the change was gradual but noticeable. He continued reporting to the same bench, opening the same ledger, testing the same categories of equipment. But the urgency that had defined June and July receded into routine maintenance cycles. No formal acknowledgement of his reports ever arrived. The technical bulletins issued by naval commands during the latter half of July remained vague. They referred to propagation anomalies and environmental interference factors. They recommended minor procedural adjustments, shorter transmission windows, modified antenna angles, reduced output power during coordination phases. None mentioned defective component batches, none referenced serial numbers, none cited field technicians. In September 1943, an internal communications assessment circulated among Allied planning staffs in Algiers and Cairo. The document analysed Axis interception capabilities during the Sicilian campaign and concluded that German and Italian monitoring stations had detected increased Allied radio traffic patterns during the early phase of the landings. The assessment stated that encryption had prevented compromise of message content. It also stated that operational traffic density may have provided indirect indicators of fleet concentration and coordination cycles. The document did not explain how such traffic had propagated beyond intended coverage areas. It did not attribute the phenomenon to equipment faults. Mercer never saw the assessment. By the autumn of 1943, the 36th Signal Repair Section was reassigned to support operations along the Italian mainland. The warehouse at Bizerte was dismantled. Equipment crates were loaded onto transports. Personnel were issued new movement orders. Before leaving, Mercer packed his tools and closed his ledger for the final time. The last entry, dated 22nd of August 1943, read simply, "Routine maintenance resumed. No change in containment behaviour on remaining units." The ledger was placed in a storage crate with other technical records and shipped to a regional signals archive. No one interviewed Mercer about the invasion. No one asked for his documentation. He remained listed in personnel files as a radio maintenance specialist with no disciplinary actions and no commendations. His service record noted continuous duty from November 1942 through October 1943, with participation in the North African and Sicilian campaigns as part of a technical support unit. In 1944, newer transmitters entered service in large numbers. They used improved shielding designs and more stable internal components. The specific defect Mercer had documented became less common as older equipment was retired or rebuilt in centralized depots. The problem faded into obsolescence rather than resolution. After the war, Allied technical histories focused on strategic planning failures, weather miscalculations, and intelligence misinterpretations during early amphibious operations. Communications difficulties were mentioned briefly, usually attributed to congestion, atmospheric conditions, or human error. Maintenance logs from field workshops were rarely consulted. Mercer was discharged in 1945 and returned to Ohio. He worked for several years repairing agricultural radio systems and later took a position maintaining equipment for a regional telephone company. He did not publish memoirs. He did not apply for veterans' recognition beyond standard benefits. In archived Signal Corps correspondence from 1943, his name appears only in routine duty rosters and shipping manifests. The ledger, catalogued under a depot inventory code, remained untouched in storage until the late 1960s, when portions of the archive were reviewed by military historians researching wartime communications infrastructure. One researcher noted the repeated references to containment failure in the margins of a technician's logbook from Bizerte. The observation was footnoted in a technical appendix. No name was mentioned. Mercer died in 1989. He left behind no record of his wartime work beyond standard discharge papers and a small collection of service photographs showing rear tents and anonymous equipment benches. The invasion of Sicily entered history as a logistical and strategic success marked by difficult weather, scattered landings, and intense resistance. The role of defective transmitters was absorbed into broader categories of operational friction. The technician who documented the flaw, weeks before it manifested across an entire fleet, remained one entry among thousands in a system built to prioritize movement over maintenance and schedules over precision. His work did not alter plans. It did not delay operations. It did not receive acknowledgement. It existed only as a quiet record of observation, preserved in technical handwriting on aging paper, inside a warehouse that no longer stands.